Hello everyone! So in this section, we're going to solve some application problems using theories we have learned on previous section. And I really recommend you to try the problems before you watch the lecture video. So the first problem is to balance the chemical equation. So the given equation here is an unbalanced chemical equation that represents how boron sulfide reacts with water to form the boric acid. So here, what it means for unbalanced is that the number of atoms on the left-hand side and the right-hand side are different. So for example, the number of S is 3 on the left-hand side and 1 on the right-hand side. So we need to find right coefficients x1, x2, and x3, and x4 to make the number of atoms the same. So in other words, we need the same number of atoms on right hand side as on the left hand side. This is because atoms can be never destroyed nor created. So we're gonna think the number of atoms as a vectors. So for example, a vector that each component represent the number of atoms like B, H, O, and S. So we're gonna write B2F3 as 2003 and H2O corresponds to 0, 2, 1, and 0, and H3, BO3 corresponds to 1, 3, 3, and 0, and H2S corresponds to 0, 2, 0, and 1. So if you plug all these things into the relation above, then that gives you x1, 2003 plus x2, 0210 equals to x3 1330 plus x4 0201, and if you move things to the left hand side, that gives you x1 times 2003 plus x2 times 0210 plus, we're going to reverse the vector instead of the variable, which gives you -1, -3, and 0, plus x4, and again 0, -2, 0, and -1. That equals to 0 vector. Or equivalently, we can write this as a matrix relation. That gives you 2003, 0, 2, 1, 0, -1, -3, -3, 0, 0, -2, 0, -1, multiplied by x1, x2, x3, x4. That gives you 0, 0, 0, 0. So here we're going to call this large matrix as A, and the vector as the vector x, and then A times x just gives you the 0 vector. So this is an homogeneous equation. And if you have the homogeneous equation, how do we find the non-trivial solutions? Well, we can find a non-trivial solution by RREF, the given matrix A. So you can start the video and finish up the calculation on your own before I give you the solution. So the first step that I would do is to eliminate the first column. What I mean is, well, I multiply by 2 on the fourth row and then subtract 3 times R1. And also it seems like we can eliminate the third row as well. So like we multiply by 2 on R3 and subtract R2 to replace R3. Then the given matrix is row equivalent to 2, 0, -1, 0, 0, 2, -3, -2, 0, 0, -3, 2, 0, 0, 3, -2. And here if you add R3 into R4, then we get 0 row on R4. And also we can reduce further on the second row by subtracting R3 from R2. Then this gives you 2, 0, -1, 0, 0, 2, 0, -4, 0, 0, -3, 2, and 0, 0, 0, 0. So from here, we can tell that x4 is a free variable And negative 3x3 plus 2x4 equals to 0. Or x3 equals to 2/3 times x4. And 2 times x2 minus 4x4 equals to 0. Or it is equivalent to say x2 equals to 2x4. And 2 times x1 minus x3 equals to 0. Or 2x1 equals to x3, but x3 equals to 2/3 x4. So we can say that x1 equals to 1/3 times x4. So we can write the solution as 1/3 x4, 2x4, 2/3 x4, x4, which is the same as x4 times 1/3, 2, 2/3, and 1. And note that x sub I counts the number of atoms of the given reaction above over here. And you can see that the common denominator for each entries are 3. So if you take x4 equals to 3, then we get x1 is 1, x2 is 6, and x3 is 2. So we get the balanced formula for the given reaction. Okay, so let's move on to the next problem. So this problem is about the traffic pattern in a freeway network where the units are given by cars per minute. So given the traffic information like 200 going into B, 40 is going out from A, and 60 is going out from D, and 100 is going out from C, we want to identify how much each traffic goes for each direction. So basically, directions cannot be reversed. So we can solve this problem by analyzing each point A, B, and C, D. And basically, the amount of the traffic that flows in is the same as the one that flows out. So for example, in A, we have x1 flowing into A, and 40 plus x3 plus x4 flowing out from A. And for B, we have 200 flowing into B, and x1 plus x2 that flows out from B. And you can fill in the blank by using the same procedure. So this gives you a system of equations like x1 minus x3 minus x4 equals to 40, x1 plus x2 equals to 200, x2 plus x3 minus x5 is 100, and x4 plus x5 equals to 60. And if you write that as the augmented matrix, that gives you 1, 0, negative 1, negative 1, 0, 40, 1, 1, 0, 0, 0, 200, 0, 1, 1, 0, negative 1, 100, and 0, 0, 0, 1, 1, 60. So here, note that we have 5 variables with 4 equations. That implies the augmented matrix is 4 by 5 plus 1 matrix, which should be 4 by 6 matrix. So you can double check whether you got the right number of rows and columns. Okay, so to solve the system of equation, we need to find the row echelon form of the given augmented matrix. So the first step should be you subtract R1 from R2. That gives you 0, 1, 1, 1, 0, 160 for the second row, and the rest are the same. And now you subtract R2 from R3, which gives you 0, 0, 0, negative 1, negative 1, negative 60 for the third row, and the rest are the same. And if you add R3 into R4, we get REF for the given augmented matrix. So here, pivot positions are 1, 1 entry, 2, 2 entry, and 3, 4 entries. So the free variables are x3 and x5. And from the third row, we have negative x4 minus x5 equals to negative 60. Or if you move x4 to the right hand side and negative 60 to the left hand side, that gives you x4 equals to 60 minus x5. And also from the second row, we have x2 plus x3 plus x4 equals to 160. Or we know that x4 is 60 minus x5, so it is x2 plus x3 plus 60 minus x5 equals to 160. Or x2 equals to 100 minus x3 plus x5. And lastly, from the first row, we have x1 minus x3 minus x4 equals to 40, or x1 minus x3 minus 60 minus x5 equals to 40, or x1 equals to x3 plus 40 plus 60 minus x5, which is the same as x3 minus x5 plus 100. Okay, so if the flow x4 is closed, then we have x4 equals to 0, which means we have 60 minus x5 equals to 0. That gives you x5 equals to 60. So if you plug this into x1, then this gives you x1 equals to x3 minus 60 plus 100, which gives you x3 plus 40. And for the x2, we have x2 equals to 100 minus x3 plus 60, which equals to 160 minus x3. So if x4 is closed, we have x1 equals to x3 plus 40. x2 is 160 minus x3, and x3 is still a free variable. x4 is 0 and x5 is 60. And if x4 is 0, then we have x1 equals to x3 plus 40. And because we cannot reverse the direction of the flow, x3 is positive. So the minimum of x1 is 40 cars per minute. So we can solve a lot of various different kind of complicated systems of linear equations by using the matrix techniques we have learned so far.